Morning, everybody.
Morning, sir.
All right, good. I'm just testing, make sure everybody can hear me. Everybody can see the screen?
Yes, sir.
All right. Okay, so let's do this. Let's do this. Let's do this. All right. So I sent hold on a second. I sent this paper for you to do. It's a revision. It's our part of our process of having continuous revision. And so we're going to be doing this paper. I selected questions from this paper based on the topics that we have covered already. All right. So this is the May 2016 paper. And we're going to work through a number of questions on it for revision. All right. Yeah, so let me leave this part of the screen because I might need to use a calculator in the first question here. All right. So let's do this. Let's do this. So first question you were to do was number 1, right here. And these are our usual calculator questions, guys. So as I say, we see in the class from time to time, persons typing in stuff in the calculator and getting the wrong answer because they're not typing in the info properly. So you need to get one of those calculators that will show this, for example, exactly as it is there. It's very, very important. I keep repeating it time and time again. And we keep seeing persons getting wrong answers with the calculator because of the limitations with those calculators. All right, so this thing is very, very important. Well, let's set up this fraction. Let's set up this fraction up here and look at it. All right, make it a little larger for you. So it's a fraction, and then on top there we have a mixed number. All right, guys, I'm back. Internet just failed me. So hotspotting. All right, you back with me? Can you see the screen again?
Yes, sir.
On him. All right, good. All right, so I said I'm continuing to type this information inside here in the calculator. So we reach there. Now we need a quarter. Complete that 2 1/4. And we're dividing all of that by another mixed number, which is 1.5. 1.5. And the calculator is telling us 0.75, which is 2/4. All right. But this question wants us to express our answer as a fraction in lowest terms. So 0.75 is 3/4 right here. All right, so this is equal to 2/4. Question said using a calculator. So I'm going to do it like that. All right, that's that. Finish. First part done. Next part is for us to use the calculator again to do this thing. I don't want us to give it correct to 2 decimal places. Again, I'm going to type this exactly as it is in the calculator there. And so it's a bracket, 2.86 plus That's 0.75, close bracket, plus that's 0.481 squared. So make sure that what I have there is the exact same thing in the calculator, and I'm seeing the value of 3.841361. But the question wants us to correct these two decimal places. And so these are the two decimal places we are correcting. And we're using this one to correct those two places. Now the one cannot increase it. And so to two decimal places, this becomes 3.84. Basically, that is it. All right, nice and easy so far. All right, but good with that so far? Easy stuff. But okay so far?
Yes, sir.
All right. Then we come to this question. Some consumer arithmetic question. It says, Paula bought and sold a computer. Well, Paul, it says he wrote his business activity as follows. So this is the cost price of a computer right here. That's how much he paid for it. This is the marked price. This is how much he's selling it for. That's the marked price. Or how much he's writing that he's selling it for, or how much he's placing on it. That's what the marked price is. So when you go in a store and you have the items on the store and see a price on it, that is what we call the marked price. But they don't necessarily sell it for the marked price. Sometimes they can give you a discount on that marked price. So the marked price, the price that he placed on the item is this. All right. But then now he gave a discount. He says a discount on the market price is 5% if someone pays cash. So if someone goes in the store and decides that they're going to pay for it cash, he's going to give them a discount of 5%. Now, if he gives a discount of 5%, it means that the person will pay 95% of the market price. All right. The person will pay 95%. That's all right. Pays 95% times the mark price. That's why MP for mark price. That's mark price MP, right? Let's put MP here. So I just put in this for information. So if you give a discount of 5%, it means that you're selling it for 95%. Question says, calculate the selling price and if the person pay cash. So the person is paying cash. This is the selling price. It's this one, right? So the selling price becomes equal to the same 95% that we said. 95%, the market not going so good today. 95% times the mark price of 1,399. That's the selling price. All right, now 95% is the same as 99 over 100 or 0.95. So 0.95 times 1,399. So they would pay 1,329.05 dollars. That would be your selling price. Let's call it selling price, SP, selling price. But okay with that? Very good. I need to answer. I know this is an interactive session, guys. I needed to answer. All right, I know that you're paying attention and everybody here. All right. Can you hear me? Can you see the screen? Just making sure.
Yes, sir. Yes.
All right, good. Then we come to the next question. It says, what is the profit as a percentage of the cost price? What is the profit or loss? Now, did he make a profit or a loss? So if he bought it for this amount and he sold it for this amount, then he's making a profit because he sold it for more than he bought it. That's a profit. And then this is still a cost price. So you're taking the profit over the cost price to get the percentage. So let's set it up. So let's set it up this way. So the percentage profit is going to be the profit because he did make a profit divided by the cost multiplied by 100. What is the profit? The profit is the difference between the selling price and the cost price. That is the profit. So I'm going to just put them up here. So the selling price is 1329.05. And also the cost price is 1065. 1064, sorry. You divide that by the cost, which is this again. I don't have to put the dollar sign, guys, because I'm going to get a percentage as my answer. Let me shift these over. I'm going to multiply this now by 100 to get your value as a percentage. I have to get the percentage profit and multiply this by 100. So that's your calculation. This is for your profit. Now, remember in the classroom, I told you that you need to do the mathematics in a way that is very efficient. So you use your calculator one time to get your answer. So some persons maybe would work out the profit first. There. And then they divide. But that is one additional calculation. It's the same with up here. Some persons will work out the 5% first and then subtract from this, which is really a waste of time. You need to recognize that if you give a discount of 5%, you are really working with 95%. And so it reduces the amount of calculation you need to get the answer. We have to learn to work efficiently. Same thing down here. Even though the profit is a part of the calculation, I don't have to show the actual profit. This represents the profit. It is built into my expression right here. I don't have to work it out and show it as a figure. Right? So I set it out in a way that I can use my calculator one time to get my answer. And so I'm going to put this in the calculator now. Fraction 1329.05 minus 1064. That's the profit on the numerator. Divided by the cost, 1064. Let's make sure it's 1064. Yes, it is 1064. All right, and then I multiply this result by 100. And I get 24.910. But remember, we work with three significant figures, guys. When the question don't tell you how accurately you should give your answer, work with three significant figures. You don't have to guess. That's 24.9. That's three figures. I put on the percentage. That's his answer there. But okay with that?
Yes, sir.
All right, good. Next question. Aha. So this is something we're doing in the class yesterday. All right. Now remember, I told you that this can be done multiple ways. It can be done where you see how much of the quantity. It's a better buy question, you know. It says orange juice is sold in cartons of three different sizes. These are the three sizes. These are the prices. All right. It says which size is the most effective buy. Just as saying which size is the better buy. Instead of saying most effective, they could have said which one is the better buy. Which one are getting more value for your money? And as I said, this can be done two ways. You can work it out by seeing how much of the juice you're getting for $1, or you can work it out the other way to say how much are you paying for 1 milliliters? Because the juice is in milliliters. You can say how much are you paying for milliliters? So if we're going to do it the method where we say how much are we paying for 1 milliliter, you need to put the money on top. You need to put the money on top of the fraction. All right, to see how much you're paying for 1 milliliter. And the one that you're paying less for 1 milliliter is the better buy. All right, and we can actually show the calculation right here now. Now, because we're going to be dividing this small number by these larger number, putting the money on top, of the fraction. It's better to work with cents so that these numbers become comparative in size. So I'm going to work these as 420 cents, 535 cents, and 580 cents. I want to see how much cents am I paying for each milliliter in each juice, in each carton. All right. And the justification, when it says justify your answer, you have to show that calculation. All right. So see it here now. For the 350 ml juice, I'm going to divide the money on top of that. So I'm going to say the cost per milliliter, the cost for 1 milliliter is the 420 divided by the 350. I'll work that out. I'll do the same thing for the others. For the 450 milliliters, the cost per milliliter is the money 5.35 cents for the cents. 5.35 cents on top of the volume of 450. I'm going to work that one out. And for the 500 mil, I'm going to put the money on top again. Cost per mil would be 580 divided by 500. So in this method, we want to see which one is paying less for 1 mil. Could have done the fraction the other way around. We'll divide the juice by the money, and that way we'll be seeing how much you're getting for $1. But we're using the method where we're seeing how much we're paying for 1 mil. So we'll put the money on top. All right, so let's do this. A calculator question again. Let's work the calculator now. So we're working these out now, right here. All right, so let's see. The first one is 420 divided by 350, getting 1.2 cents. For this one is 1.2 cents. 1.2 cents, 1.2 cents for 1 milliliter of juice in that carton. The second one is 535 over 450, and that we're paying 1.18 cents. So this one is less, you know, because this is the same as 1.20. This is 1.18. This is less. If you write in the 2 decimal places, this will be 1.20. And this is 1.18. So this is less than that right now. So this one so far is better than that one. Eh? Let's look at the third one, which now is the 580 cents divided by 500 milliliters. That's 1.16 cents. So this one is a better buy. The largest one is a better buy because it's cheaper. Each milliliter is less. So this is sufficient for your justification, guys. Right? When it says justify your answer, if you show them this calculation, that is sufficient. And you're gonna tick this one and say, okay, 500 mil is a cheaper buy, is a better buy. 500 milliliters is the better buy. Better buy this one, you're getting more value for your money. Or you could write the most effective buy, same thing. But okay with that? That's my answer. When it is spending less for 1 milliliter, see cost per milliliter. For 1 milliliter, you're paying $1, you're paying 1.16. For this 1 milliliter, you're paying 1.18. This one up here for 1 milliliter, you're paying $1, 1.2 cents, and 1.18 cents, and 1.16 cents. All right, that finishes question one. Everybody okay with that one? First one? Just want to make sure. All right, let's assume that silent means consent. All right, let's move to number 2. I don't think I need a calculator here now for number 2. This first one is first to factorize this. That's the difference of 2 squares, guys. Remember, you have to factorize it completely. All right. Now, firstly, there's a common factor of 4. So you always want to look for your common factor first if there's any highest common factor first. I'm going to show you a mistake that some person made with this one, right? So I'm going to factorize the highest common factor first, which is a 4. And I'm left with a squared minus 4. Because when I divide this 16 by this 4, I'm getting 4. Then inside, you know, I have the difference of 2 squares. And so it will be 4 into a squared minus 2 squared. That's writing inside you have the difference of 2 squares. Let's remind ourselves of what the rule is. If it is a squared minus b squared, then that factorizes into a minus b times a plus b. That's the difference of 2 squares rule that we're using here. All right, let's just call it a rule. And so we're going to be the difference of these two numbers and the sum after we drop the square. So it becomes 4 into a minus 2 a plus 2. And that is the answer right there. Now, what some persons did, which was a mistake for this question, was to write these now as 2a squared minus 4 squared. Because this 4a squared can be written as this, you know. And so it looks like the difference of 2 squares still. And then they proceeded to do 2a minus 4 times 2a plus 4. And they left that as the answer. But the reason why this cannot be the answer is because the question said completely. So it means that you should not have any factor that can be factorized further. And if you look at this factor, for example, there's a common factor of 2 in there. We can factorize this again with a 2. Similarly, we can factorize this again with a 2. So these two are not factorized completely. And so this would not be a correct answer. So even though you factorize it, you would not have factorized it completely because these factors that you end up with can be factorized further. And it could end up at the same answer that we have here, because if we factorized this one, let's go back for the purple, then we would get 2 bracket a minus 2. And then now if we factorize this one, we'll get again 2 bracket a plus 2. And then this 2 times 2 will give us the 4. So we could bring this 2 times 2 together, put it as 4, a minus 2, a plus 2. And then you see that the answer will be the same there. But I think this is just too much work. All right. So remember, when you're doing a factorization, right, and it's, for example, this type, where there are 2 terms, and you know it could be the difference of 2 squares, you look for the highest common factor first. You look if there's a highest common factor first. Factorize a common factor first. And then, you know, you check here, you know, inside you can factorize further, which it can, as the difference of 2 squares. All right. Back to this one now. That's our 3 terms quadratics. Let's go back to the process, remind ourselves of the process. The process really is to expand this out into 4 terms by splitting this middle term. We want 4 terms there. All right. I want to split that middle term into 2 parts. All right. So you can factorize it by parts. The process is to multiply the 2 n coefficients. All right. So multiply the 3 times the negative 8. And 3 times negative 8 is negative 12. Looking for positive 24, negative 24, negative 24. Factors of 24 that add to 2. Now I can see that is 6 and 4 off the bat, because 6, 4 is 24. And the difference between 6 and 4 is 2. Well, let's say you can't see it right away. You want to go down the factors of negative 24. I want to see the ones that add to positive 2. Now, since you want factors of this negative number, one factor will be positive and one will be negative. So the first 2 factors to try will be 1 and 24. Give the larger one the same sign as that. So the larger one going to make it positive, smaller one negative. But then 24 minus 1 is 23. It's not 23 you want 2. So you cannot accept this one, so I'm putting an X on that. The next 2 factors of 24 will be 2 and 12. Give the larger one the same sign as this up here that you want them to add to. Put the 12 on the plus on the 12, minus on the 2. And then 12 minus 2 is 10. Again, you don't want 10, you're looking for 2. So you don't want 10, put the X on that. The next 2 factors of 24 with 3 and 8. Give the larger one the same sign as this up here. Make this one plus, make this one negative. Then 8 minus 3 is 5. You don't want 5, you're looking for 2. So you don't want 5. Cross it out again. The next 2 factors of 24 are 4 and 6. So you see, I went down all the factors. Give the larger one again the same sign as this, which is the plus, smaller one the minus. Then you see that 6 minus 4 is 2. The same 2 that you want up here, the positive 2. And so you're going to use that. So what it is, 2y using negative 4y plus 6y, or you can put the 6y in front. All right, that's what they want to do. So the next time, you have to keep telling students all the time, don't give a lot of space to work. So we have to be very efficient, right? Keep saying it in class. So I'm going to split this now, and then this 3y squared comes back as 3y squared. I'm going to factorize it by putting the 6y in front of the minus 4y. So I'm going to write it as plus 6y minus 4y. That's what I split this into. I always do that checkpoint. It's a checkpoint where you check to ensure that when you split it into, will give you back this middle term, which it does. Because 6y minus 4y is 2y, and you bring back this negative 8 here. Minus 8. And so I've broken it out into 4 terms. Now we can factorize by parts, first 2 terms and the second 2 terms. So the highest common factor in these first 2 terms right now is 3y. So you factor out the 3y. 3y out of this leaves us with a y. 3y divided out of that leaves us with a plus 2. And you must always have the same thing in the bracket over here. So to ensure that I have the same thing in the bracket over there, I always write about the same thing first, which is the y plus 2. And I can see some plus or minus value must go inside here. Some plus or minus value must go inside here. What value that is? The factor that you're taking from this to end up with that. How can we know it? We can divide this by that. Divide the negative 8 by 2, you're going to get negative 4. Or we can divide this one by the y. Still going to get negative 4. But so in between here, we have minus 4. And so the y plus 2 is a common factor. And then it therefore becomes y plus 2 is a common factor. And so it's a 3y minus 4 times that common factor give us our result. 3y minus 4 times the y plus 2. That's the answer. Now, if we did it, and we put the y plus 2 in front of the 3y minus 4, then this is still correct. That is still correct. So this is the answer right here, guys, whichever one. But good at that? But okay?
Yes, sir.
All right. Simultaneous equations right here now to solve. So to solve simultaneous equation, I'm going to use a process of elimination because both of them are linear. We're not going to use a substitution method. And since this is a positive y and this is a negative 2y, I'm going to use a method where I can eliminate the y terms by adding the 2 equations. But I need this to become a 2y first. What I'm going to do is simply take this first equation and multiply it by a 2. Because I want the y to become a 2y. So I'm going to take this first equation here, multiply it by a 2. And you can actually do it this way on the exam paper, guys, as I'm doing. Multiply this by 2 becomes 4x. Multiply this by 2, it becomes plus 2y. Equals, multiply this by 2, it becomes 6. I'm not going to change anything on this one because I already have my negative 2y. So this one will remain as it is. I'm just putting it on here so I can add the value, add them together. So this comes back unchanged. 5x minus 2y equals 12. Now if I add up everything, add up the left side and add up the right side. As if I'm adding up all the values here and adding up all the values here. So the 5x and the 4x, they add to 9x. So I'm getting 9x. Then this positive 2y and negative 2y, they cancel out each other. And on this side, the 6 and the 12 giving me 18. Then to make x a subject, I just need to divide by 9. So I can write it. If I divide by 9, I can write it this way. And so the x becomes 18 over 9, which is 2. All right. Then now to find the y value, I have to find the corresponding y value. I can take this 2 and substitute it in the first equation right there for the x. So I'm not going to say and. When I substitute it, it's going to become 2 times 2 plus y equals 3. If I substitute in the first equation, I don't have to say it. So I know say and, I say I don't have a lot of space to work with, guys. So that's why I'm saying you have to be very efficient. You can't be writing a lot of unnecessary stuff. All right. So what we're doing, took the 2 and we use it in the first one. I could have used it in the second one as well. Where I realized that it take me more time. I've substituted one that can give my answer easier. All right, so I substituted it in the first one. That's where this 2 came right here. Because I substituted the 2 in the first equation. All right, so let me write it here. So 2x plus y equals 3. I'm going to sub x equals 2 in this equation, right? Into that. And this is what we get. And this is 4. When I split the 4 by here, I'm going to get 3 minus 4 is negative 1. So the y equals negative 1. So I can write my solution line. The solution is that x equals 2, y equals negative 1. Or you can put it in a bracket like this. 2, negative 1. That's acceptable if you put the answer like that as a solution. But okay with that?
Yeah.
All right, good. So simultaneous equations when they are lines, very easy to do. Don't complicate it, all right? No need to complicate it. Keep it simple. All right, next one. This question says, table below, this is a variations question. The table below shows corresponding values of variables x and y. When x varies, see, this is the variation now. Y varies directly as x. So if that's a direct variation, means that y is equal to a constant times x when it's direct. If it was inversely, instead of directly, if this was inversely, then it would be y equals k over x if it was inversely. Well, this one is directly, so it's y equals k times x. Question wants us to calculate the value of t and u. See, this one is not asking us for any k. All right, we need to improve the way we do these questions. All right, so since not asking us for any k, right, and see the small space you have to work, I'm going to show you now how you can actually do it without finding the k. So what you do with this equation that we have established based on the variation is make k the subject. So because the k is a constant. What this is saying is that the k, if we divide by the x, then the k will be equal to y over x. What this means is that the y over x is always the same. The y over x is a constant value. The y value divided by the x value is constant. All right. So we can use this pair. So we can say, okay, this y over x and this y over x is the same as this y over x. Let's set it out. Y over x is a constant. All right. So it means that this y value over this x value is equal to this y value over this x value. Or you can put it the other way around. This y value over this x value, u over 10, is going to be equal to this y value over this x value, 3 over 6. Because the k is always equal to the y value over the x value. This is what we're using. We don't need to actually find the k. We don't have to work it out. I'm showing you now how you can do it without finding the key, because some questions you have to learn to do it without having to find the key. So you write the expression of what the k is. The k is always the y value over the x value on the pairs. So this y value over this x value is going to be equal to this y value over this x value is going to be equal to this y value over this x value for all the pairs. And that's what we're going to use. So from this one, we make u the subject. Well, this becomes a half, really. We'll make u the subject by multiplying up the 10. So you see that the u becomes 3 over 6 times 10. That's 5, you know. The u equals 5 because that's a half. Half of 10 is 5. It is the same thing on this pair. So this u value, this y value over this x value equal this y value over this x value. So we can set that up again. All right. Sorry. Oh, sorry about that. So when I say again, the 9 over the t, that's this y value over this x value, is equal to this y value over this x value. Again, which is the same 3 over 6. And you're trying to make t the subject. All right. Now, can make t the subject easily now, because if 9 over t equals 3 over 6, which is a half, you can literally take the reciprocal of this side and take the reciprocal of this side. In other words, flip this side and also flip that side. All right, so you get t over 9 becomes 6 over 3. Where 6 over 3 is actually 2. I can multiply the 9 now. And so the t becomes 6 over 2 times 9. 6 over 3, sorry. 6 over 3 times 9. 6 over 3 is 2. 2 times 9 is 18. So this becomes 18. And those are your answers. Think you understand that, guys? The way to do it without finding the key. Find an expression for the k, which is this. And that expression holds true for all the pairs. For all the pairs. And this is saying the y over the x is the same value all the time. That's what it is. All right, guys, that's the method that I used here. But I go to that?
Yes, sir.
All right, good. I have to learn to do mathematics the easy way. Since it didn't ask us for a key, we have to learn to do it without having to find a key. All right, so I did say we're skipping over number 3. And I'm skipping over number 4 because this is the topic that we're going on to next. Plain and solid geometry, right? So we'll skip over number 4 on this paper. So we'll get back to this question some other time. So that's why we're skipping over number 4 today. All right, because this question related to those things. So skipping over number 4. All right, and so we're at number 5. See? All right, this question said the diagram below, not drawn to scale, see? Not drawn to scale, guys. You cannot go by how anything looks. Something look isosceles, you cannot assume. Something like a right angle, you cannot assume, right? You cannot assume anything by how the diagram looks. You cannot put any ruler on the diagram. You cannot put any protractor on the diagram. No instrument. It's not drawn to scale. It says it shows two straight lines, JK and the JL, that are these two. This one and this one. They intersect a pair of parallel lines. All right. So these are the parallel lines, EF and GA. So let me hear. Parallel lines. So these are parallel lines. And these are like transversal lines. Remember, once you have parallel lines crossed by any other line, so for example, you have these two parallel lines and they are connected with this line, right? Those two parallel lines connected with that line. They have some Z angles forming and you have some U angles forming. You also have corresponding angles forming. Once you have parallel lines crossed by another line, again, these two parallel lines again are again crossed by this line. And so because they are crossed by that line, you have U angles forming and you have Z angles forming. Let's look at some of the things that we can have, that we can see off the bat with the parallel line. So let's work with this one, for example. So first I can come here, come along the parallel line and go down here. That's a Z angle, you know, this angle and this angle equal. But then now, if I come down this line, come along this line, go back up this parallel line, then these two angles are co-interior angles. They add up to 180 degrees. That's a parallel. Because those parallel lines, they are like angles in the U. You can see the U right here, the U. Angles in the base of the U. So those are some of the things. Well, let's answer the questions. I guess I can explain it as we go, each one. All right. Question says, determine, given answer for each, given a reason for each answer, the value of x. That's this angle right here. And this one kind of easy because you see, you have a straight line. And this line divides that straight line into two angles that add up to 180 degrees. Because total angle on the straight line to this point is 180 degrees. So the 128 and the x must add up to 180 degrees. Total angle on the straight line is 180. Let's just use this one is quite simple. So the x becomes equal to 180 degrees minus 128 degrees. All right, which works out to what? So 180 minus 121st, 80 minus 21st is 60, and then minus 8 more, you get 52. Correct? That's correct? If you're paying attention.
Yes, sir.
All right, and so must write the reason. The reason is that total angle on a straight line is 180 degrees. Total angle on a straight line is 180 degrees. That's what we use, a straight line here. Total angle on a straight line through this point is 180 degrees. All right. Total angle over here is 180 degrees over this point. 180 degrees on the straight line. And that 180 is broken down into the x and the 128. The 180, and so we subtract 180. All right. Next angle I want is y. Now we did say that we have the u angles here now. Right? They come down this parallel line, come along this side, go back up here. You have the u angles. So these two angles add up to 180. But then we could also use corresponding angles. Watch this now. So you have this line that is parallel to this line. And this straight line, this blue line that I'm going to draw, is crossing both of them. So this straight blue line must interact with the parallel lines in exactly the same way. So for example, the angle that the blue line makes with the red parallel line on here, it must be the same thing over here. They are called corresponding angles. And so that y angle there is just equal to, in fact, I shouldn't have any theta on this now. Let me go back. Let me go back a bit. Question is asking us for the value of x. Everything important. Just check back. So it asks for the value of x. So we're actually not supposed to put on any degree on the x. Let me show you why. Because the angle is x degrees right here. And so the x is just a value. So let me take the degrees off it. So the x becomes just 180 minus 128. I don't need the degrees. The angle is 52 degrees, but the x itself is 52. Because if I put back the degree on the x here, then I put the degree back on that. So the x degrees is 52 degrees. And so the x is just 52. All right. So let's pay attention to that. But anyway, so these two angles are corresponding, as I said. Right? These two angles. Both of them, because of the parallel line, both of them are relating or interacting with this blue transversal line the same way. So they correspond. They're corresponding angles. So they're equal. So I'm going to write the y equals 128. Easy. Corresponding angles are equal. That's my reason. Corresponding angles are equal. But if you want to, if you didn't say them as corresponding angles, you could have also said that these two angles are co-interior angles, U angles. If I do it like this, could have also used the U angles down this parallel line, along this line, and joining them back up this parallel line. And these two angles now would be co-interior angles, add up to 180. So the x and the y also add up to 180. So you could do it that way. Right? Remember, this is 52. So the y would be 180 degrees minus by the 52. You're going to get back the 128 from here. So, you know, we could do it that way. But it's good to see the easy way, which is to see them as the co-interior angle, as the corresponding angle, sorry. Then I want angle W. Let's see where angle W is on the diagram. So angle W is this angle up here. All right. So let's see now. All right. Angle W. All right. So I'm seeing angle W as a part of this triangle. I'm also seeing angle W as a part of this triangle. To me, it kind of makes sense to work in that triangle because I have this angle here. What about this angle? You might say, I need that angle. I'm gonna find W. So that angle is gonna be 80 degrees. Show you why it's gonna be 80 degrees now. Because if I look at this parallel line up here, these two parallel lines up here, and they are joined by this line. Then these two angles are co-interior angles, U angles, this one and this one. That's why I'm saying this angle is 80 degrees. All right, so that angle is 80 degrees. And then now I can come and work, after having found that angle is 80 degrees, I can come and work in this big triangle now. Where I know two of the angles. But this angle here is, what is it again? 52? That's 52. Yes, 52. Remember this angle is 52. And so these three angles now add up to 180. This one, 52, and the 80. They add up to 180 degrees. Right? So that's one way we could do it. So what I'm seeing is that these two angles add up to 100. These two angles add up to 100. I see the way to do it already, but I'm just connecting with the 100 degrees. Right, so the 100 degrees will be the 52 degrees, the 52 degrees plus the W. And so we could get it that way. All right, I'm just trying to see if there's an easier way to do it. Maybe there is an easier way to do it, but I'm not seeing it right now. So no, I've not used up the 100 degrees yet, so I guess that's it. Another way to look at it is this. What is another way to look at it? Another way to look at it. You see, that's the thing with these questions. There are always multiple ways to do them, right? You have this line and this line parallel, and they are joined by this transversal line. And this angle right here, let's mark it in purple, is X. Between those two, there must be X here as well. So this angle must be X corresponding. And then total angle on this, so this angle is X. And then total angle on the straight line over here is 180. And this is 100. So inside this must be 80 degrees. So what you can do to help you actually help the questioner, right? So we're getting about the same thing. What you can actually do to help the question, right, is to actually join, put in some of the angles on the diagram, right? So I would, for example, come here and do like this. It's okay. This angle, I'm going to mark it and say it's 180 degrees minus 100 degrees, which is 80 degrees. So I'm showing why this angle is 80 degrees. And then this angle, I'm going to mark it as X. And the X is 52 degrees. I'm putting those on my diagram to help with my solution for W. All right, so this is X because it is corresponding. So I'll put those on my diagram and then I'll make my work easier. So come down here and also something like C diagram. Then I would say W becomes 180 minus the 52 and the 80, right? The 52 and the 80. So it's 180 minus the 52 and the 80. And that would give me my W. So it becomes 100 minus 52, which is 48. Is that correct? Well, 48. Don't put on the degree. 48. 48. But I give that. But understand that?
Yes, sir.
Yes, sir, I understand.
All right, good. So, and the reason is that total angle in that triangle now, we're using total angle in the triangle is 180. And we did reference the triangle up here. So see there, I could say C triangle, where these points do have any letter, but see the diagram, right? And I'm referencing those as my answer. They'll give it a mark. When I can see that that's what you did, CSEC will give it a mark. So I would put these markings on my diagram I say C diagram because I'm going to be using them. And it's 48. And I say total angle in triangle is 180. Total angle in a triangle. All right, to the right triangle is 180 degrees. All right, that's what we did. So we adjust to the diagram. So we get some, I do a lot of space to do a lot of calculation to show. So I put some of the calculations on my diagram right there. Mark it, put them there. Say to the examiner, see the diagram. And then I show my work and put my reason. All right, that's it. It's only 2 marks. So you have to do it the easiest way possible. So use up the diagram if it's on the page. Diagram is a part of the solution. All right, good. Part B now. It says the diagram below shows triangle RST and its image R prime, S prime, T prime. So this is the object, this is the image. All right, I see there's no change in terms of orientation, no change of size, no change in rotation. So this is a movement, guys. It's a translation. I can look at it and see it's a translation. Nothing has changed. All it has done is move from one location to another. I see the translation. They're going to ask me to describe it anyway, so might as well figure it out from now. Just need to see what happened to one point alone, like S. It's a translation. How many units to the right? 2 units. Check if it's actually 2 units. 5 to 7, that's 2 units, yes. And then vertically, one centimeter to 1 unit, so yes. Make sure the scale is correct. So it's 2 units to the right. And then how many units down here? 1, 2, 3, 4 units down. So it's 2 to the right. 4 units down means -4. So that translation 2, -4. All right. So they're gonna ask us it, describe it fully. So makes sense. That translation 2 units to the right, 4 units down. Translation 2 units to the right, and 4 units downwards. Now, technically, you can say given by. Technically, if you say translation, if you write this instead, translation, and you write 2, -4 like this, they are supposed to give you your marks. But because I said describe fully and put that in word, bold letters and all of that, cap letters, I think safe thing to do is to write it out like that, right? 2 units to the right, 4 units down, and then adding this and say given by the translation matrix 2, -4. All right, that's that. Then it says triangle RST is reflecting line x equals 6. And it says on the graph, draw triangle R double prime, S double prime, T double prime, the image of RST under this reflection. And I want us to write the coordinates of the point R double prime. All right. So this triangle now, this one, the original triangle, right? Is reflecting line x equals 6. You need to show that line on the diagram. All right, let me erase these. All right, let me erase these. I'm going to show a line x equals 6 here. The vertical line through 6. X equals 6. The vertical line passing through 6. That's how I learned about those lines. That's our mirror line. And you're reflecting this in the mirror line. So remember, do reflection 1 point at a time. Image distance equals the object distance. All right, let's zoom it up. So this S is 1 unit to the line, it's written blue. It's 1 unit to the mirror line, it's going to go 1 unit on the other side to here. So S is coming here. That's S double prime. Now this one is 1, 2, 3, 4 to the line. It's going to go 4 on the other side. 1, 2, 3, 4. So it's coming, let me write it back. It's coming to here. All right. So it's coming to here. Remember, the length of the thing is 3 units. That's the stay is 3 units, right? The size doesn't change. But R prime is coming right here. R double prime. And then this one is coming right below it. that number of units, 1, 2, 3, 4. Same number of units over here, 1, 2, 3, 4. All right, so it's coming right below the R on the other side over here. That's T double prime. And you just use a ruler and draw a triangle like that. Use a ruler and complete a triangle like that. That is your image. And this I put on the double prime on it. And I wanted to write the coordinates of this point, which will be 10, out here will be 10. Let's put it, out here will be 10. CH9, out here will be 10. 10, and this y value will be 3. So this point R prime is 10, 3. Put it down here. R double prime is 10, 3. 10, 3. That's it. Question done. But okay? Very good?
Yeah.
All right. Number 6. We have to do number 6 as well. So let's go. Number 6. Number 6 is a coordinate geometry question where they show the line. I like this because I don't have to do any calculation most of the time for this. I can look at the question, look at the diagram and know everything. So the x plus y equals 3 lines. It crosses x, y-axis at 3, crosses x-axis at 3. At a gradient of -1. So rise -3, run 1, run 3. So it becomes -1. Or I can use another point, for example, between here and here. Rise -1, run 1. So the gradient is -1. But anyway, let's continue. It says, determine the equation of a line which is parallel to this line. So the gradient of that line is -1 because it's parallel. And pass through the origin. So if we pass through the origin, the C is 0. The equation of a line is y equals mx plus c at all times. And so it becomes y equals -1 times x. Because the gradient is -1. All right, let's write out everything. Plus 0. Because the c value is 0. But we have to put -1 here. You can just put -x. So y equals -x. Y equals -x. That's the equation of a line. All right? It becomes x plus y equals 0 as well, if you transpose it. So it's going to be another x plus y line, right? Just as it passed through the origin. So it will go like this. That's another x plus y. All the x plus y lines run parallel to each other now. So if it's x plus y equals 3, it passes through 3, 3. If it's x plus y equals 5, it will pass through 5 and 5. And so if it is x plus y equals 0, is the x plus y line that passes through the origin. So we could have known it from here. It's parallel to x plus y, so another x plus y line and pass through the origin. So this x plus y equals 0. So you could have actually just written this on this information, just wrote this one. That's the same equation. We could figure it out with the gradient and y-axis intercept as well as I did here. All right, so you could just write down that one if you want it. X plus y equals 0. Then the one that is perpendicular to it now, and also pass through the midpoint of AB. All right, so that line that we want next, it passes through the midpoint of AB. Right, so it's actually going to be this line, you know, y equals x, you know. You can literally just see it has to be that line, but let's use it out. Let me take this off. So it passes through the midpoint of AB. So AB passed through 3, 3. The midpoint of AB must be 1.5, 1.5. Right? It passed through, not 3, 3, it passed through these points, 0, 3, and 3, 0. So remember, I know the midpoint is the average of the x values. These are x values. And the average of the y values. These are your y values. So the average of the x values would be 1.5. Average of the y values would be 1.5. So it passed through this point. 1.5, 1.5 here. And then it runs perpendicular to this. So if you run perpendicular to that, so it's like this is the perpendicular bisector of the line segment AB. That must pass through the origin here. Well, the question maybe wanted to work it out. So I could know it's a line y equals x, you know. That's what I like about the graph question. You can literally just see it. It's a line y equals x. Pass through points where the x and y value is the same, and also pass through the origin. All right, but let's work it out. Let's say I want to calculate it, right? All right, now firstly, perpendicular. It is perpendicular to this line. This line has a gradient of -1. So the gradient of a line, perpendicular lines have negative reciprocal gradient. So the gradient of line 2, let's call this line 2, the one that we want now. Let's put it in red. Perpendicular gradient is -1 over the original gradient. Let's call this line 1. First line I want, or first line over line 1. So if I put the -1 under here, I'm going to get just 1. So the gradient of the line that we want is 1. Gradient of the line that we want is 1. Sometimes when the question is easy, it's harder to show a working, you know, because it's so easy. It's almost like you're complicating it if you try to show a work, to try to do calculation and question that don't need no calculation. Believe me. So the gradient of that line is 1. Then now it pass through the midpoint of AB. So it means it pass through the point. Let's call that point P, 1.5, 1.5. All right. So if we're using a calculation method to do it, all right, enter the gradient of 1. So the equation, if using that formula, the y minus yp equals the gradient into x minus xp. If using that method with the point and the gradient. So the y minus 1.5 equals the gradient of 1 right here into x minus 1.5. Because this xp value is 1.5. So you will see that the 1.5 cancels the 1.5, and you're left with y equals x in the end anyway. But I don't like to do questions and work out questions that don't need any work. So you're going to get y equals x anyway as the answer. So, but as I say, you could see it from the graph, guys. It has to be that line, y equals x. All right, could see it. But that is it. 2 marks for that. Never really need any work. That is it, y equals x. All right, then we'll come to this one now. It says the function, that's a quadratic function, on domain -2 to 4, means that that is the range of the x values from -2 to 4. The table below shows corresponding values of x and y. So 5 selected values of x, right? So these are 5 values. Remember, I know what that means that because of this range, you have even values like, for example, 0.5, 0.4. You have all values in this range, but they have just selected these 5 integer values to use. All right, but remember the fraction values also work because you have the full range. It says we are to complete the table by calculating values, inserting values in the missing value in the missing sections or missing values of y here and here. A lot of the times we can know those values by recognizing that the quadratic function is a symmetrical function. All right, so you look for the symmetry of the values. Like for example, these two symmetrical and these two symmetrical. What comes between them? So I know that this must have a 0. Since there's a 0 between this negative, this 5 and this -3, there must be this 5 and this -3. It must have this 0 in between over here as well. So I know that right here is a 0. What comes here, you have to work out this one because there's no symmetry to show it. You have to work it out. All right, but between the 5 and the -3, between the 5 and the -3, you have a 0, you have a 0 here. Otherwise, you can take this tree and plug it into the function. But I'm going to do the mathematics easy. I'm looking for the symmetry first. So the 0 must come back here in between, but the values are symmetrical 0. I have to work out this one for the 1. I don't have anything to use it as a symmetry on. All right, so I have to work it out. And actually, it might be the axis of symmetry. right, based on these values. Might be the axis of symmetry. All right, this 1. So I'm going to take the 1 and plug it inside here to get what the value is. So I'm going to write x equals 1. Y becomes 1 squared minus 2 times 1 minus 3. That's what we get when we plug the 1 inside here for the x. And this is 1 squared is 1. This becomes minus 2 and minus 3. So the whole value works out to be negative 4. So it means that we'll put the negative 4 here. And this looks like the minimum value. That's unique. It's a unique lowest value. And the values are symmetrical about here and here. All right. So the axis of symmetry is going to be the average of these two values, which is actually 1. So this represents where your minimum point is right here. 1, negative 4. All right. That's the axis of symmetry. It says on the same axis on part 5, draw the graph. So to draw the graph, basically I want to plot these values, plot these points. All right, on the same graph that we have over here with a line. Okay, so we don't want to have these on it. All right, I need to plot these points. So there's negative 5, let me write them out and then. All right, negative 2, negative 2, 5. Let's plot them, negative 2, 5. Plot them in red. Negative 2 up to 5 right here. So 1 point is here. That's already a point of intersection. Then negative 1, 0. Negative 1, 0. That's right here on the x-axis here. Then we have 0, negative 3. That's here, the y-axis intercept. Then we have 1, negative 4 right here. 1, negative 4 right here. Then we have 2, negative 3. See, 2, negative 3. 2, negative 3 will be here. Then we have 3, 0. See, 3, 0. 3, 0 is right here. Then we have 4, 5. The last point was 4, 5. 4, 5. So 4, 5 is up here. So 4 here, so up to 5 is up here. 4, 5. So those are your points. And this becomes the minimum turning point. So we're going to make the curve turn there. Remember, don't use any ruler on the graph. All right. It's a smooth curve that you have to draw. So we're going to draw a smooth curve through these points. Don't come down. I could miss that one. Let's go again. Let's go again. Also have a turning point here. Goes back up here. And through these points. And that's it. All right. I'm sure there's going to be something asking us about these points of intersection. X values where they meet. That negative 2 and the same 3 that is here. All right. I'm sure these questions go that way all the time. All right. Let's see. So we have drawn the graph. And then answering questions now. It says using your graph. Using your graph, we have to complete each of the following statements. Ready? It says the minimum value, not the minimum point, you know. The minimum value occurs when x equals right here, 1. On the graph, you can see it. Right here, the minimum value is 4, negative 4. So when x equals 1. Then they ask for the minimum value. If you want the minimum value, it will be negative 4, lowest y value. Well, it occurs when x equals 1, right here. The minimum value is when x equals 1. All right, when x equals 1. 1. The value of x for which it, you know, this equals this. You know what this is? This is where the line, this is the line, you know, and this is a curve. This is where the line equals a curve now. Remember the line was x plus y equals 3, you know. If I transpose the x, I'm going to get y equals minus x plus 3. This represents the line right here. And then this is the curve, y equals that. So this now is basically representing the point where the line and the curve meet. All right, so this is where the curve equals the line where they meet. So those two x values that I showed you. The line and the curve meet here where x equals -2 and where x equals 3. X equals -2 and 3. So it's where x equals -2 and where x equals 3. And that's it. Finishes that one, number 6. Very good at that. Easy question.
Yes, sir.
Sometimes the question is easy, the harder to explain, you know. Because it's so easy, believe me. The harder to explain because it's so easy. It's like you don't know what to tell. Because that's so easy and straightforward. All right, so we reach number 9. I did give you this question to do as well. It's a functions, all right? It's asking us for a lot of inverse functions and so on. But let's just answer the question. First part, give us these two functions. And they want us to write expression for each of the following. They want f to the -1. So we're doing the inverse of this, all right? So I'm going to start by saying f equals 2x minus 7. Some teacher will put y equals 2x minus 7. And then interchange and put x equals 2y minus 7. And then make this y the subject. I'm doing the same thing, really. But that I'm still using my f. And so I'm going to make, from the inverse function, this f, which is on this function, range, becomes x. And then I put 2. This now is my domain on this function. It becomes the inverse, range of the inverse, f to the -1. So instead of x and y, I use f and the f to the -1 minus this 7. Then I'm trying to make this a subject. I'm going to transpose the 7 first and get x plus 7. I'm going to divide under the 2 afterwards. That leaves me with f to the -1. And so that is it. I can write that therefore f to the -1 is equal to x plus 7 over 2, and I can put in my of x. The of x that I have here, it's a function of x anyway. The inverse is a function of x. So that's it. Then they want g to the -1. That's the inverse of this one. So again, I'm going to do it. I'm going to start by saying g equals x squared plus 1. All right, so there's something about the inverse of a quadratic function, but let's not get into that. So we're going to assume that we're going to take the square root. We're going to have to take the square root. We're going to take the positive square root, all right? Because the inverse of a quadratic function can only have an inverse if you restrict the domain. We will learn that at a higher level. But don't worry about it for now. Just going to take the positive square root from a square root. So we're going to inverse this as usual. The g becomes x. This x becomes g to the -1. So I'm going to write g to the -1, what's under the square, right? Plus 1. Then you want to leave this in here as a subject. Ready? First thing is to move over the x. And then we're going to get x minus 1 equals g to the -1 squared. We want to get rid of this square, so we square it both sides. And so the square root of x minus 1 becomes g to the -1. And so we can write it now. And so therefore, g to the -1 is the square root of x minus 1. We can put in by the of x now, of x. All right, so I found 2 of them so far. Then they want f of g of x. So let's write out both of them so we can just show how it works. So the f1 is 2x plus -7. And the g of x was x squared plus 1. And you want f of g. How you form f of g is to put the g into the f. So this is the g. I'm going to take the g, all of the g. I'm going to move it and put it into the f where the x is. That's why you put that function into another one. Composite them. All right. And so our f of g of x is going to be this construction that I'm showing in red. 2 into x squared plus 1. So where the x was, I'm placing this there now. All of the g, sorry. And then I'm going to have the minus 7 right here. All right, and let's simplify it. It becomes 2x squared, because this 2 times 2 now is 2. 2 times 1, sorry, is 2. 2 minus 7 is negative 5. So I must write 2x squared minus 5. That's f of g of x. So far, so good, guys. So far, so good.
Sir, yes, sir.
All right. So it's bright and sprightly, like a soldier man. Then we want the inverse, f to the minus 1. So since we have this function, we can use this to the inverse, right? Inverse this one. All right, so let's do it. We can do this another way too, you know. We can do this another way. They didn't tell us how to do it. We can do this another way by recognizing that this is actually equal to g to the minus 1 of f to the minus 1. Remember, the inverse of a composite function, f of g r to the minus 1 is equal to g to the minus 1 of f to the minus 1. I could reverse these in here. So the g to the minus 1 come out in front. So we can actually calculate this way. Now, remember, we have these two functions and we have them up here. Let's copy them down. We have these two functions, we have the two inverse functions that we can use. Right? Let me copy them down. Like this. Yeah. Copy them down. So we actually can use them right here. So these are the two of them. Let's move this one up and show you how the construct will work. So what it is wait and show you, is that this means that we're putting the f to the minus 1 into the g to the minus 1. Like so. And so we're taking this f to the minus 1. I'm going to bring it and put it into the g to the minus 1 here. Where the x is. That's where it's going. And we can finish it off and write this equal to square root over everything, x plus 7 over 2 minus 1. Do the mathematics the easy way. That's it. Now, let me show you something now, just for practice. Well, this can be written simplified because this is same as 2 over 2, right? So we can write this as a square root of x plus 7 over 2 minus 2 over 2. All right? And then now, when you add the fractions, you're going to square root everything over 2 because this have the same denominator now. 7 minus 2 is 5. So you would have x plus 5 over 2. So simplify like that. So why am I doing this? I'm doing this to show you that we could have also gotten this inverse of the composite function working from this. Let me show you now. We're going to get the same thing. All right. For the purpose of us doing this quickly, to show that we get the same thing down here, I'm just going to write this as y and x, right? Just for simplicity. I'm going to tell the inverse of it just to show you. Let's do it right here. Show you that we get the same thing. So if I call this y, just for simplicity, y equals 2x squared minus 5. And I inverse it, then this y will become x equals 2 times this x will become y squared minus 5. What we'll do now, firstly, to make y squared the subject, we'll take over the 5 and then divide the 2. So we'll get x plus 5 over 2 equals y squared. Then to get rid of this square, we'll have to square root both sides. So it means that I can take off this square and square root this side. And that would leave me, if I take off the square here, it's gone. And see, I'm getting the same thing. X plus 5, square root of x plus 5. This will be the inverse now, the inverse. This will be the inverse now, right? After interchange and then make this y the subject, I have the inverse of this function, which is what we wanted here, which this now is the same thing I have down here. But to do the mathematics the easy way, to do this part of the question the easy way, is to use our knowledge of this thing that we have in the box. The more things you know, the better. It's the easier way to find this. All right? Could have been done that way. Then the next part now says, show that this equals that. Show that this equals that. All right, so let's go again. So this got to work out this and work out that and show it is the same value. So let's work step by step. Let's work out this side first. So FGR to the minus 1 of 5 means that we're going to be putting 5 inside here. Because remember, that's what we have now. This is FGR to the minus 1. So it will become square root of 5 plus 5 over 2. But this is 10. 10 over 2 is 5. It becomes the square root of 5. And then we're going to do this side now. So we're going to say, and g to the minus 1 of f to the minus 1 of 5. Means we have to do this part first. Put a bracket around it. We're going to do this part first. Remember now that the f to the minus 1 is disappearing now. This. So this kind of like we're taking the 5 and we're putting it in this function first. All right, so this then will become, I'm doing it this way because I don't have a lot of space, guys. I keep telling you that don't give a lot of space for these things. It becomes g to the minus 1 of 5 plus 7 over 2. 5 plus 7 is 12. 12 over 2 is 6. So this then is g to the minus 1 of 6. And then g to the minus 1 of 6 now is to plug the 6 into the g to the minus 1 function here. And so it becomes g to the, sorry, put in the g to the minus 1, don't put the back. We're going to just plug the 6 in the g to the minus 1 function. We're going to get the square root of 6 minus 1, which is the square root of 5, same as this one. So 2 of them equals square root of 5. So therefore shown that this equals square root of 5. So f g r to the minus 1 of 5 is equal to g to the minus 1 of f to the minus 1 of 5. And both of them equal the square root of 5. That's what we have shown. But I keep telling you guys, you don't give a lot of space to do the work. 3 marks for this, you know. You don't give a lot of space to do the work. So we have to be efficient in how we solve the questions. Right? We have to be efficient. And the way to be efficient is to know the material so well. You know what we can skip over, because like you know where you're going. You know where you're going. When you know this, when you know the thing well enough, you know where you're going. And so you know what lines you can skip out. And you know the most efficient way to get to your answer. But that is it, guys. All right. Then we'll come to this. Oh, I said you were to leave out this one. I don't do this topic yet. So I was skipping over that one as well. All right. That is variations question. No, it's a distance time graph. Rates of change question. So skipping over that. Very good. But okay?
Yes, sir.
All right. Just want to make sure everybody's still there. Want to make sure. All right. So let's continue. Let's continue. All right. Just skipping over that one. Skipping over this one altogether. Then we come to our circle theory. All right, so this question says the diagram below not drawn to scale. So you cannot go by how anything looks. So for example, these lines look parallel, you cannot assume. And this looks like a rectangle. You cannot assume. You cannot go by how anything looks in the diagram. You have to just work with the information that you have that is presented and also with the theory. All right, the question says, show the circle center O. EH and EF are tangents. So they have two tangents from a single external point here, guys. The two tangents rule question. And those two tangents, they are coupling up with these two radii. This one and this one. Let's just identify some of the things from now. So it means that this angle is 90, and between a tangent and radius, this angle is 90. So these two angles right here now, they are supplementary. Because that blue quadrilateral is now a cyclic quadrilateral. Remember, the two tangents and the two radii, they form a cyclic quadrilateral. So those two angles in there, they add up to 180 degrees. All right? That's the red angle right here now. Can be formed by doing 180 minus the 44. All right, let's just make note of that. But let's answer the question. Let's answer the questions. So it tells us that that's a straight line, FOG. These are diameters, you know. That's a diameter. We're going to pass through the center. So this is actually 90. And it's obtained by a diameter is 90 degrees. And this also is a diameter. This one is also a diameter. And so this angle down here is 90 degrees. All right. So that's a 90 up here as well. So this is actually the rectangle then. It becomes a rectangle because the four angles equal 90. All right. So let's continue. It gives us this angle down in here between the two tangents is 44. All right. It says calculate given reason for answer the measure of angle EHF. Where is that now? EHF. That's this angle in here. Now, what we have to realize now that this is an isosceles triangle. Remember, we call this tangent and this tangent, they are the same length. All right? The two tangents from an single external point, they are equal in length. So that red triangle is an isosceles triangle. This side and this side equal, so these two angles that I've marked, they are equal. And total angle in a triangle is 180 degrees. It is isosceles. When you know one angle in an isosceles triangle, you're blessed because you can find the other two. So this angle right here is going to be 180 degrees minus the 44 divided by 2. All right, because the two of them equal. These two angles equal the same thing. All right, so that is it. And you see, they'll give a lot of space for it to work, guys. Notice I keep telling you, they'll give a lot of space to work. So let's work out though. That becomes actually 90 minus 22, which is 68, right? Because 90 minus 20 is 71st minus 2 more is 68. So let's work out to 68 degrees. 68 degrees. So this is 68 degrees. Let's write it. I want to show this calculation as my reason. I'm going to say it's 180 degrees minus 44 degrees divided by 2. And my reason, don't give it a space. I say given reason, but they don't give it a space. That's equal to 68 degrees. I'm going to tell them that that's an isosceles triangle. That triangle there. EHF is isosceles. So triangle EHF is isosceles. Let's see what space is put out the word isosceles, but that's isosceles. And the total angle is 180 degrees. So isosceles, I'm dividing by the 2. All right, that's that. All right, let's take this off now. That angle is 68 degrees. Let's put it on the diagram. As you work them out to put them on. So this is 68 degrees. And this over here is also 68 degrees. So now we have a situation angle between a tangent and a chord. Wow, so within 68, hold on. Angle between a tangent and a chord. The 68, so the chord is supposed to subtend 68 up here. This angle is also 68. I should ask it, right? Similarly up here. is 68. Sorry. Similarly, up here is going to be 68 here. Tangent and chord rule. All right, so let's leave those two on the diagram. 68. I'm just thinking ahead, and that's how you do the question sometimes, right? So I think ahead and see what you have. Then I want angle FGH. FGH. F. See, I'm going to want, FGH right here. It is 68. Why? Why is it 68? It is subtended by this chord. And the chord is making 68 degrees with a tangent. Tangent and chord rule. Angle between a tangent and a chord, this angle equals this angle. Equals the angle subtended by the chord. So that angle is also 68 degrees. Let's put it 68 degrees. 68 degrees. Tangent and chord rule. Angle between tangent and chord equals angle subtended by the chord. And that's it. So that angle up here is 68 degrees. Let's write it. Let's put it on the diagram. You find them, you put them on, right? Remember, that is the practice that you must have. As you find the angles, you put them on. Populate the diagram with the angles that you know. So this angle up here is 68 degrees. So obtained by this chord. Same chord subtending 68 degrees up here as well, right? Put it on. So this angle over here also is 68 degrees. Those two angles, 68. All right, let's see now. Next angle I want is JHE. Let's see what that is. JHE. JHE. Draw it in blue so you can see what I want. JHE. J to H to E. That's 90 degrees. Angle between the diameter and the tangent. But JHE is actually OHE as well, right? Radius and tangent, angle between tangent and radius. So that angle is 90 degrees. Let's go down there, right? The 90 degrees here. I want to say angle JHE is also angle OHE, right? There. Same as angle OHE. It is this 90 degree here. Tangent and radius rule. Right? Angle between tangent and a radius is 90 degrees. That's it. You don't give a lot of space to write out all the reasons, right? So that's why I tell you have to be efficient with what you see. I keep telling you in the class, you're seeing it for yourself. You don't have a lot of space to answer the questions, to write out a lot of stuff. They don't expect a lot of stuff. So let's get to it. Next angle I want is JGH. I will just work out that this angle is 90. Let's put it on 90. J to G to H. That's also is 90, you know. Why is that 90? It's obtained by this diameter. JGH is obtained by that purple diameter. Diameter rule. JGH is 90 degrees. Angle obtained by diameter is 90 degrees. Let's write it down here. So this angle is 90 degrees. Angle subtended by a diameter. is 90 degrees. Some say angle in a semicircle is 90 degrees, same thing. That's the reason. Have to be efficient to your work. Anything else? Done. Done. Everybody good with that? Everybody okay?
Yes, sir.
All right, let's do this question now. So, it's an elevation question, apparently. So give me this distance here. Looks like I'm gonna have to work in this triangle. If I told you in the class, the more things you know, the better. Right? That this exterior angle is equal to the sum of these two. So this is 22, and this one is 40 minus 22. The more things you know, the better. 40 minus 22. All right? We like to give this particular situation a lot of questions. All right, so that is 18. And if I have to work in this triangle, and I know that this is 18, then I can use sine rule because I have this pair opposite each other that I know. I can use that pair with this angle on this side over here. I can find this side using sine rule right away. I can tell you that. But let's answer the questions. All right, I was thinking ahead. It's just my experience with the questions that I'm doing this, right? Some thinking ahead, and when you get experience and you practice and so on, you can see where the questions will lead. All right, so the question said the diagram below, not drawn to scale, shows two ships, R and S, at anchor on a lake. So on calm waters mean that they're not moving, so they're on a lake. They're not moving, all right? So this is like on a lake. All right. It says FT is a vertical tower. So this is on a lake, and this is a vertical tower. And the vertical tower is, out of the water there, where it's jutting out of the water. It says FSR is a straight line. It's a straight line. And then they give it this distance is 150 meters. That's the distance between the two ships. It says the angle of elevation of T, which is the top of the tower, from R and S are 22 and 40 respectively. So from this one, the angle of elevation looking up here is 40. From this one, angle of elevation looking up here is 22. So this question helping you by giving the diagram. In the past, to give you this information, you would have to draw the diagram. Now they give you the diagram, so it's a lot easier. It says F is the foot of the tower. See there, F is the foot of the tower. Now this is horizontal, this is vertical. That's why this angle here is 90 degrees. So this is input in a 90 degree angle right here for you. Makes it easier. Calculate giving your answer to one decimal place where appropriate. The measure of angle RTS. RTS. Here. See, question asking for it. Told you. So we're gonna do it the easy way. Now, some people say total angle of straight line is 180 and put this as 140 degrees. And then so total angle of triangle is 180 to get that one. Gonna be the same thing, right? Gonna be the same thing. But an easy way to do it is to know that this angle is external or exterior angle of this triangle. So this angle out here, marked back in blue. This angle out here on the extension of the triangle is equal to the sum of the two opposite interior angles. So since this one down here is 22, then this one is 40 degrees minus 22 degrees, which is 18. All right, so let's put it down here. That angle is 40 degrees minus 22 degrees, which is 18 degrees. I don't have to put no reason, right? It's not a show, we just show the calculation and you go. It's not a question we're showing the reasons. But that is it, 18 degrees. Put on the diagram as you find it, 18, put down in red. So I'm coming up here, I'm gonna put my 18 degrees right here. All right. I'm sure another way could know it's 18. Now, suppose I put in a horizontal here that is parallel to this. Let me show you quickly. So put in a horizontal here. Then if I use Z angles, bam, 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 then all of this will be 40, right? And if I go and I use Z angles here, bam, 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 and this angle will be equal to this angle, should be 22 degrees. And so you would see, sorry, you would then see that if this is 40 and this is 22, then the difference between them will be right here, 40 minus 22, which is the same 18. All right, so I'll show you another way to read it out. All right, let's get back to the question. This is 18. Sometimes the teaching in me get too much, because I just want you to understand everything. So sometimes I go a little bit too much that I don't need to. But anyway, let's go. That's 18 degrees. Then I want the length of ST. Told you, I want the length of this side, ST. So we're going to have to work in this triangle to get ST because the only distance we know is a part of that triangle. And we cannot use so-called to on that triangle. We have to use either the sine rule or the cosine rule. So now we can use the sine rule because I have this pair opposite each other, angle and side that I know both of them. And I have this angle that is opposite now to the side that I want right here. I'm going to use the sine rule on that pair. All right, angle and side opposite each other. So sine rule, tell the examiner sine rule. We're using sine rule for ST. So it's going to be ST over the sine of the angle opposite to the ST. Not a lot of space to work. As I see, I keep telling you now. I think it's a joke. Keep telling you in the classroom, you have to be efficient with your work. Not a lot of space to work with. ST over the sine of 22 degrees opposite to it equal the side that you know, which is the 150 over sine of the angle opposite the 150, which is 18 degrees. And so the ST will be the subject when you multiply the sine of 22 over here. So because I don't want that space, I'm going to split the screen, split the space, and write that ST comes equal to, and you always put the trig behind the number. Put the number in front of the trig. All right, so you don't confuse the calculator. It becomes 150 sine of 22 degrees divided by the sine of 18 degrees. So ST equals what? And it's a 1 decimal place, right? 1 decimal place. So an exact answer, though, we'll have to put the 1 decimal place because I said we're appropriate. All right, let's work this out now. Calculator. I see I set up more, so I'm calculating once, using one calculation to finish. So it becomes a fraction of 150 times the sine of 22, dividing that with the sine of 18. Calculate in degrees, look up there for the DEGS. All right, that is 181.8, 1 decimal place, 181.8. Unit of measure is what? Meters? Yes. Distance must have a unit of measure. Meters. As I find it, I'm going to put it on my diagram. Put it on the diagram here. Remember, if you find something, you put it on the diagram, guys. Very important. You want your information on your diagram. I'm going to put it on it. 181.8 right here. Down in the red so I can see it. I know it. So I'm going to write my 181.8 meters. On my diagram. I can work in this triangle now because I know two things. Remember, if you have a right angle triangle, I know any other two things, angle and side, I can use so-called tower now to find anything else. I can find the height of the tower, or I can find this distance. What am I going to ask us for the height of the tower? Let's see. See, the height of the tower. I know these things. When you practice a lot, you know what I'm always asking you. So to use the height, to find the height of the tower in the triangle, from this angle now, this is the opposite that we want. And we know this is the hypotenuse. Opposite and hypotenuse are connected with the sine of an angle trig ratio. So we're going to use sine of the angle for the 40 degrees to find that opposite side, which is the height of the tower TS. Start by saying sine of the 40 degrees equals. Start that way. Don't start by saying TF equals. All right? Don't start that way. Start with sine of the angle. When you get more experience, you can start with the TF. All right, but I'll start with the trig ratio that you have to use and transpose for what you want. So sine of the 40 degrees equals the opposite side, which is the TF that we want to find, FT, I call it FT, over the hypotenuse, which is this that we just found. Okay, that's it. Opposite over hypotenuse. Sine we have to use. And then now to find the TF, we're going to take this and multiply it up here. So the TF or FT becomes equal to 181.8 and the sine of 40 degrees. Use a calculator one time. So 181.8 times the sine of 40 degrees. And that is 116.9. 116.9 meters is the height of that tower. That's it. But good at that. But okay. Hello.
Yes, sir.
All right. Let me just check something here. I'm getting a lot of birthday wishes. Thank you, guys. Thanks, everybody. Thank you very much. Everybody been sending greetings. Thanks. Okay. All right. Last question. Last question for today. Number 11. And remember, guys, I wanted to redo the question. Redo the questions for me, please. We're getting closer and closer to the exam now. Redo the questions. Watch over the video. Read the questions. While you do the questions, you watch the video when you come up on a stage or whenever you need help. Look back at the video to see what we did. All right? But you have to learn to do these questions by yourself. All right, this question says the position vector of points A, B, and C relative to an origin ORB. So give us some position vectors. That one. Like these questions, we did position vectors. They want the vector AB, that's a displacement vector. Remember, it's O times the last minus O times the first. Displacement vector AB, B is the last and the A is the first. So it's O times the last minus O times the first. So it's OB minus OA. Put that on top. Equals, I'm just going to write the answer, guys. I'm doing this one minus this one. So it's 6 minus 2 is 4. 1 minus a negative 2. 1 minus a negative 2 becomes 1 plus 2 is 3. That is it. But go to that. But okay.
Yes, sir.
And then AC is a similar thing. O times the last minus O times the first. Mathematics the easy way. OC minus OA. So I'm doing this one minus this one. Just subtract the values and put the answer. Don't complicate it. 10 minus 2 is 8. And 4 minus a negative 2. 4 minus a negative 2 becomes 4 plus 2 is 6. Now, before I go any further, I can see that these two are parallel. Because this one is twice this one. If I multiply that one by 2, I get this one. So I know that they are parallel. And they also have a common point. And so they're actually collinear. You can see that already. All right. The AC is a bigger one. The AC is the larger one. It is twice the AB. So I can write from now that AC is 2 times AB. And A is a common point. Before we go to the next question, you can see it already. The bigger one is 2 times the smaller one. And they have a common point. So the 3 points are collinear. Let's see if they ask anything about that. Let's see. See? They said, hence determine whether they are collinear. Give a reason. Yes. Yes. The big one, can see it, is clearly 2 times the small one. This is 8,6 and this is 4,3. I'm going to write that. Do mathematics the easy way. AC, the big one, is 2 times the small one. So the two conditions for collinearity, you have to write them. One, AC is parallel to AB. That's the first condition for you to have collinearity. The second thing that must happen for collinear points is that you have a common point, which you do. A is a common point. So you have to write it. A is a common point on the two vectors that are parallel. Therefore, you can conclude that the points are collinear. Therefore, A, B, and C are in fact collinear. That's it. Done. 3 marks for that. And this one didn't need a calculation because the values are all whole numbers and they are so glaringly, it is glaring that one is, the big one is 2 times the small one. The AC is 2 times AB. So I don't have to go through the fandangles. That's it. Done. Next part down here, the matrices, part B. It says determine the value of X if this is singular. Remember, singular matrix has no inverse, has no inverse. Has no inverse when the determinant, it has no inverse because the determinant is equal to 0. Now the determinant is equal to 0, then this product equals this product. The diagonal products are the same. So the determinant equals 0, doing the mathematics the easy way now, guys. We're getting more advanced. When the determinant is equal to 0, the diagonal products are equal. So this product, for example, which is 2x, is equal to this product, which is 3 times 4. And when you subtract them to get the determinant to be 0. So if when you subtract the values to get the determinant is 0, it means that the two diagonal products equal. Now this over here says 12. It is 2 times 6 that is equal to 12. So x must be equal to 6. Done. But I go with that. But okay. And how much space to give to this easy question. And the ones up there that require more work, they don't give so much space. But okay with that, I want to know before I can move on.
Yes, yes.
Yes, sir.
All right. This one says N and P are 2 by 2 matrices. See them here? They want us to multiply them. All right. So they set them up and multiply them. Because remember, you have to multiply the rows of the first matrix, the columns of the second matrix. Let's write them out. 4, 1, 3, 2 times 1, 1, 5, 2, 1. See, again, they don't give a lot of space for it to work. Let's zoom it up. Remember, using the rows of the first matrix to the columns of the second matrix. All right, let's do the calculation here. And see if we can show the working goes one more time again. All right, let's go. First value here, 4 values getting. The first value here is in the first row and the first column. So to get it, we have to multiply this first row with this first column. Or you multiply them. You multiply the first element in the row by the first element in the column, second element in the row by the second element in the column. First element times first element, second element times second element. 4 times 1, and 1 times 2. 4 times 1 is 4, 1 times 2 is 2. Then this value over here now is in the first row and the second column. So to get it, we're using this first row with this second column. How do we multiply the row by the column? First element times first element, second element times second element. First element times first element, second element times second element. 4 times 5, 1 times 1. So remember the first element in the row times the first element in the column, then the second element in the row times the second element in the column that you're using, right? So we're gonna get 4 times 5 is 20. 1 times 1 is 1. Let's move this bracket over here. Then now the next value is right here. It is in the second row and the first column. So to get it, we have to use this second row with this first column. Multiply them again the same way. First element in the row times the first element in the column. Second element in the row times the second element in the column. First element times first element. Second element times second element. 3 times 1 and 2 times 2. 3 times 1 and 2 times 2. 3 times 1 is 3. And 2 times 2 is 4. So it becomes 3 plus 4. Then the last value out here now is in the second row, second column. So to get it, we have to use this second row and this second column. Multiply them the same way. First element times first element. Second element times second element. First element times first element. Second element times second element. 3 times 5 and 2 times 1. 3 times 5, 2 times 1. 3 times 5 is 15. And 2 times 1 is 2. And then we'll just write the final answer for this. So 4 and 2 right here is 6. 20 and 1 is 21. 3 and 4 is 7. 15 and 2 is 17. That's the matrix. It says now, given that Pn is equal to this. Now, note what they have done. They have switched them around, switch around the order. I will know that matrices multiplication is non-commutative because you see, these two now are not equal. They're not equal. Not equal. Which is what happens in matrices. When you switch around the order, the result is different. You said determine whether matrices multiplication is commutative. It's almost testing your knowledge of the word. It is not. You can say since NP is not equal to Pn. We can say, I don't want to write a lot, I just want to say non-commutative. Therefore, non-commutative, I'll just write it this way. Let's write it this way. Pn is not, NP is not equal, it don't matter. NP is not equal to Pn. Therefore, non-commutative. Non-commutative. That's the key thing that I'm looking for. I don't have to write no long. It's only one mark. You don't have to write no long statement. I have to be efficient. All right? I have to be efficient with our answer. They're looking for this. It's not commutative. All right? Let's say non-commutative. I want to put this on the paper to give you a marks, but I'm also writing the reason. All right? So NP is not equal to Pn, therefore non-commutative. I'm answering this question. It is non-commutative. Don't write no long epistle for that 1 mark. That's it. And I only give 1 mark for this multiplication. It's beyond me. 1 mark for multiplying all of that. But anyway, everybody getting the same 1 mark for it. So you have to make sure you get it right. Next question, determine n to the minus 1. What is n again? Let's write out what is n again so I can do the inverse. N is 4132. 4132. All right, so remember now, n to the minus 1 is 1 over the determinant of n times the adjoint of n. 1 over the determinant is this product, which is 4 times 2 is 8, minus this product, which is 3 times 1 is 3. Multiply by the adjoint. Or we do the adjoint. Interchange the elements on the first diagonal. Interchange them, switch them around. So it becomes 2, 4. Leave the other 2 on the second diagonal and change the sign. Leave them where they are, change the sign. So this 1 becomes a negative 1 here. And this 3 becomes a negative 3 there. And this under here right now is a 5, right? This under here is a 5. That's 8 minus 3 is a 5. So my final result will be to divide each of these values with a 5. So my answer is simply going to be 2 over 5 minus 1 over 5 minus 3 over 5 and 4 over 5. That's my inverse matrix right there. It says now, hence calculate the value of x and y on this. And what we must realize is that this matrix is our n, right, that they gave us up here. And the hence means that we have to use the inverse, but we're going to use this one, the fraction outside. So, since we're trying to find x and y, we're going to take the n to the minus 1 and put it in front here. We can write it. This is really n, right? Write it here. And this is really the n matrix. So I want to take the in to make this the subject of a transpose the inverse in front here. All right, simple matrices transposition, guys. Simple. Let's do it in blue. So the xy that I want is going to be equal to the inverse matrix, the interminus. So I can put over here for the example to see now. Xy is going to be n to the minus 1 times the 1, 2. But this is the n in front of the xy here. So the inverse goes in front there. And the inverse is this, but I'm going to work the one of the fraction outside, 1 over 5. Leave the fraction for last. I'm going to put the 1 over 5, and then the 2 minus 1 minus 3, 4. That's my inverse matrix. And I'm multiplying by the 1, 2. 1, 2. Then I leave the fraction for last and work the numbers first. So xy becomes equal to 1 over 5 times. Again, I'm multiplying rows of the first matrix by the 1 column. I'm going to get 2 values here. All right, 2 values I'm going to get. I'll put in the bracket afterwards. So, first element times first element, second element times second element. That's to get this first value. It's in the first row, the 1 column. So it's first element times first element, second element times second element. So that becomes 2 times 1 and minus 1 times 2. 2 times 1 is 2, minus 1 times 2 is negative 2. That becomes a 0. All right, let's close the bracket now. Right here. Then now the second value here is second row 1 column. So to get it, we're going to use this second row with this 1 column. So it's first element times first element, second element times second element. Minus 3 times 1 and 4 times 2. Minus 3 times 1, 4 times 2. Minus 3 times 1 is negative 3. 4 times 2 is 8. We can write the final answer now. Because this becomes a 0. 0 divided by 5 is still 0. It's going to write 0. This becomes a 5. 5 divided by 5 is 1. It's a 1. So the answer there is 0, 1. I can just double check it because I don't like those simple. I'm just double check it. If the 4, 1, 3, 2 times the 0, 1, it's going to give me about this 1, 2. So it'll be 4 times 0 and 1 times 1 is 1. And it'll be 3 times 0 is 0 and 2 times 1 is 2. So I can accept this answer. It works. put a different color on it. This is like a test. Change the color to purple. Didn't change. This is like a test to test my answers. Change the purple. Alright, so this is like a test that I'm doing to test if the answers. If the answer is correct. You don't have to do this, but I just wanted to make sure. So that is it. So this is the correct answer right here. Oh, we're not done yet enough. I'll find it right, the value of x and y, right? This was a matrix. So from this now, the x is equal to 0, the y is equal to 1. You have to write those because that's what you're asked for, right? See? Calculate the values of x and y. So you can't just give them the matrix and stop. You have to explicitly write what x is and what y is to answer the question. That is it. End of this test. And that is that for today, guys. In tomorrow's class, we're going to be doing the topic of plane and solid geometry. Yep, plane and solid geometry tomorrow in class. But all right. Very good. Hello.
Yes, sir.
Hello.
Please.
But all right. All right, guys. So you know the drill. Go over the questions. So please, more maths equals better maths. Study hard, pass easy. Study hard, pass easily. Can't attain great results. I can't attain maximum results by doing minimum work. If you want maximum results, you have to do maximum work. All right, so put in the work because we all want very excellent results. So you have to put in the work to get it. And your work for today, for class tomorrow, is to redo the questions, use the video to help you. If you did the question before, the ones especially that you didn't get right, those are the ones you want to focus on. All right. If you didn't do it, you need to go and do it. Time is getting closer and closer to the exam now. You need to be sharpening up. All right, guys. So I'm giving up my birthday time for you today. So it's so important it is for me to do this for you. So because I want you all to do well. So you have to do your part. I'm doing my part. You need to go and do your part now. All right, guys. So see you all in class tomorrow morning. Bye. Bye, everybody. All right, I gone. Everybody saying anything, I gone.